Hi, this is Mr. Mack. Want to have a discussion about the remainder theorem. Now, the remainder theorem says that if p of x, and remember when we say p of x we're talking about some polynomial, is divided by x minus c, the remainder is p of c. Now, to give you, to remind you or give you an example of this, let's let p of x be, and we'll just choose something off the top of our head. Let's make it at least x cubed. X cubed minus 4x squared plus 5x minus 7. And what we're going to do is I'm going to show you, let's let c equal 2. Now, the remainder theorem in this particular case then says p of 2 is the remainder when we divide p of x by x minus 2. So first of all, let's divide p of x by x minus 2. So can we grab just this piece right here, clone it, and throw it down here, and go down and get it. All right, so what we're going to do is we're going to divide this by x minus 2. And remember, in polynomial long division, we look at the first term here and the first term there. By the way, all the terms have to be written in order of decreasing power, and if there are missing ones, we have to put in 0 as a placeholder. X goes into x cubed, x squared times, and then we multiply x squared times negative 2 is negative 2x squared, and x squared times x is x cubed. Now, what I taught you to do, if you had me, was to make one mark on the, we want to subtract this polynomial, but what I taught you to do was to make one mark on this term that you're dividing and then add. So what we'll do is, now that I've made one mark, change the sign on each of these terms. We'll add, we get 0 here, and we get negative 2x squared here. That went a little too high there, maybe. There we go. And now we bring down the next term, 5x, and we look at, again, the negative, we look at the x and the negative 2x squared, we get negative 2x. Negative 2x times negative 2 is negative 4x, positive 4x actually, and negative 2x times x is negative 2x squared. Again, we're going to make one mark on each term in the polynomial we're trying to subtract, and then we add. We get x minus 7. X goes into x minus 7 one time. 1 times x minus 2 is x minus 2. Once again, make a mark on each term so that we can add, and we end up with negative 5. So the remainder, when our polynomial, x cubed minus 4x squared plus 5x minus 7, is divided by x minus 2, gives us negative 5. Now, the other part of the theorem says that's the same thing as p of c, or in this case, p of 2. So what we're also going to do is we're going to figure out what p of 2 is. P of 2 is, what is it? Well, it's going to be 2 cubed minus 4 times 2 squared plus 5 times 2 minus 7. Let's see if we can pull that over here. Let's just undo that little line there. Yeah, now pull this over. There we go. Now, let's go back here. That's going to be 8 minus 16, which is negative 8, plus 10, that's 2, minus 7, negative 5. So notice p of 2 is negative 5, and the remainder, when we divide it by x minus 2, is also negative 5. Now that's what the remainder theorem says. Now you might ask yourself, well, why? And the answer to that is really kind of intriguing, and I want to show you why. So let's see if we can't do a couple more things here that should have meaning to you. And I'm going to take all of this and kind of make it smaller, move it out of the way. There we go. Now, remember when we were learning to do polynomial division, you also learned a thing called synthetic division. Now, to do synthetic division, you had to have a linear divisor. In other words, x minus 2 had to be first degree. And what you did was in the little half square, you put the 0 of the divisor. In other words, what you put in for x that makes x minus 2 0, which is 2. Then you wrote the coefficients of the terms, and they had to be in order and none missing. We have 1, negative 4, 5, negative 7. And then what we did was we drew a line, brought the first one down, multiplied by 2 to give 2, and we wrote that above the line. We added negative 4 and 2 is negative 2. Multiply, we get negative 4, put it above, and add again, we get 1. 2 times 1 is 2, and then we add, we get negative 5. Now, this synthetic division told us since this one right here was an x cubed, this one right here was 1 degree less, or x squared. So we were able to write x squared minus 2x plus 1 with a remainder of negative 5. Okay, but now let's take a look at p of x again. Let's see if I can get, how did that get? Oh dear. Smartboard is not behaving real well for me yet, but okay. Let's just write it again. Blue, where's blue? Maybe this is blue right there. Okay. So we've got x cubed minus 4x squared plus 5x minus 7. There we go, and we can maybe get rid of this. Okay, now if we wanted to find, if we wanted to, this is p of x, we could factor an x out of these three terms. So that would be the same as x times x squared minus 4x plus 5, and then subtract 7. But we could also factor the x out of these two, and that would give us an x parentheses x minus 4 plus 5 minus 7. Now, notice if we used these directions right here, p of 2 would become, we start on the inside here, subtract 4 from 2, and then multiply by 2, and then add 5 to that, and then multiply by 2, and then subtract 7 from that. Now notice, let's go back up here to the synthetic division, and what did we do? Well, we took 2, and we subtracted 4 to get negative 2, and then we added 5. We multiplied by 2 to get negative 4, then we added 5, and then we multiplied by 2, and then we added negative 7, which is exactly the same thing that we did here. So notice this synthetic division problem right here also is synthetic substitution, with this being the final value. And so because of that, the remainder theorem, that's how the remainder theorem works, and that's how you'd really prove it in a general case, that P of C is the remainder when P of X is divided by X minus C. Now, the next thing we talk about in Algebra 2 is the factor theorem, which is really almost an automatic result of this result. If you think about it, if the factor theorem says X minus C is a factor of P of X if and only if P of C is 0. Well, if P of C is 0, that means the remainder, from the remainder theorem, that means the remainder when you divided by that polynomial, that binomial, was 0, which means that that binomial goes into the polynomial evenly, which means that it's a factor. And so, therefore, the factor theorem is almost an automatic and obvious result of the remainder theorem. Now, I think that's all that I wanted to say, so at this particular point, I'm going to sign off with an, and we're done.